Hello. So today I wanted to talk about some of the essential data-related Python functions. There's a lot of videos already on YouTube talking about basic operators in Python and how to get started. But from a data manipulation point, I just wanted to talk about how you can use variables and what they look like and to just get acquainted with them. So variables are the same variables you'd see from algebra class, except they contain more than just numbers whenever you're coding. So we have simple data types, your basic integer, so I have x equals 3 here. They're whole numbers, they can be positive, negative, or 0, but they can only be integers. Or we can also have decimals. In code they're called floats, and you can designate them as I have done with y here. You can also have strings. Now strings aren't just words, they're a series of characters that you can manipulate. As I'm showing here, you can have numbers, letters, and special characters all in the same string. And the last simple data type is the Boolean, which can be true or false. So if we look at the logic here, we have x equals 0. If x is less than 1, this should print. So if we move up in complexity, we also have collection data types. We can have a list here. It's just like a shopping list. They're changeable and they're ordered collections. So every time you pull up this list, just like your shopping list, it's going to be exactly how you left it unless you changed it. So it will always say apple, orange, then grape. Or you could also have tuples. These are shopping lists where you can't change the contents of them, but they'll always contain this order. So apple, orange, grape. Or you can also have sets. They're changeable, but they're unordered collections. So every time you look at this shopping list, the order could change. Right now it's apple, orange, grape, but if you look at it again, it could be grape, apple, then orange. What's also unique about this is that whatever is in a set cannot be duplicated. There can only be unique instances within the set. And for the last collection data type is a dictionary. This is exactly like what the name implies, a dictionary. You can open up the dictionary to any random page, and at the top left there'll be a word. And you could go down and find the word you're looking for in the dictionary. But in code, you can connect your keyword to a set of values. So these are connected because they're kind of round, and you can search for this key and retrieve this list. It's a way of organizing large amounts of code. For the example here, we're going to look at the output. So what happens if I, again, go through a list versus a set here? So we have apple, orange, grape as it appears. However, for the set, it was not in the same order. It went grape, apple, then orange. For special data types, we have a range function, and this can output a sequence of numbers starting from 0. The Python index always starts at 0. So although this would give you 10 characters in a list, it would start at 0 and end at 9. Whenever I first started, that was very annoying. It's still annoying. I still make the same mistake, and you will too. And then pandas also has its own data types too. So there's a series, which is basically a one-dimensional array, exactly like the list, but the contents can be indexable. So 1, 2, 3, 4 can be referred to by their position. So one can be referred to as the first position, and so on. And a data frame is exactly like an Excel spreadsheet. You can have your column up top and your rows on the side, and you can designate that using the same notation as the dictionary with your key in pairs. And then for NumPy, you can also create an array. We're also familiar with this series. These are kind of the same things, except while the series, you can index these. Say the index of 1 was like Monday, Tuesday, Wednesday, Thursday. The indexing for the array is always numerical. So to exemplify this, in NumPy, what it's really useful for is simulating data. So what you can do is simulate a uniform distribution, put it into a data frame, plot it in a scatter plot on randomness. But what you should appreciate from this is how you can progress up from these various small data types and compound into larger concepts. So you can do larger manipulations in the code.